Good evening, everyone. Okay, today I will present about our AI Battlesnake project, and we are from Group 2 Chidori. With deadline, unleash the power of AI, redefine the future. Okay, I would like to introduce our group members. Let me begin by introducing our first member, which is Nabil Kumar Silver. Uh, he is a captain, and the second one is Sharwin, data analyst, and the third one is myself, Maclean Moses, visual designer. Okay, we will move to the challenge one, which is Battlesnake piece. Okay, for Battlesnake piece, the piece stands for performance, environment, actuators, and sensor. Okay, for performance, we will focus on two essential metrics. First, we will analyze the number of turns the snake takes before disappearing, which directly reflects its survival skills and decision making process. Second, we will examine the length of the snake during the game, a measure of its growth and efficiency in gathering resources. Second is environment. We will discuss the better snake that pose both threats and opportunity, walls that set boundaries, and the ever precious food that fuels snake's growth. Understanding the gaming platform is essential to excel in this competitive world. That one is actuators are the driving force behind the better snake's movement and actions. We will explore how the snake's direction and movement are controlled, which plays a vital role in outmaneuvering opponents and seizing strategic position on the board. And the last one is sensor. We will learn about how the snake senses wall, crucial for avoiding collisions, and how it detects food, ensuring it stays nourished and powerful. Additionally, we will discuss how the snake sense opponent better snake, a skill that can be a game changer in head-to-head confrontations. Okay, next for challenge one process. Let's explore the key steps involved. First, we have to create a game platform, the heart of all Battlesnake action. This is where all the magic happens and players compete head to head to prove their snake's superiority. Next, we will into the coding to create Battlesnake. This is where our creativity and coding skill come into play. We will design the logic and behavior of our Battlesnake, making it a formidable opponent on the board. Okay, once the Battlesnake is ready, it's time for game creation. We will put our creation to the test and watch it navigate the arena, seeking out food and outmaneuvering other snakes. Finally, to showcase our Battlesnake in the official Battlesnake arena, we will paste the URL for Snake into Battlesnake account. Now it's all set to take on other snakes and compete for victory. Okay, next we will move to solution for challenge 1. To begin, we create an account and simulate our snake in the game. By observing its movement, we gather crucial data that will be used to create a piece for our better snake. The piece repetition starts with performance, where we evaluate our snake's success based on its length and the number of turns it can survive before disappearing. These metrics define its efficiency and survival skill. Next, we will explore the environment our better snake will face. It includes food, walls, and other snakes, all of which influence our snake's strategy and decision making. Actuators come next, defining the direction and movement of our battle snake. These controls are essential in navigating the arena and gaining an edge over opponents. Lastly, we focus on the sensor for our battle snake. They include the ability to detect food, walls, and the movement of other snakes, providing valuable input to make intelligent and strategic moves. And that's all from for challenge 1. We will move to the challenge 2.
The challenge 2 will be avoiding walls. The solution for avoiding walls is a function in this section of the code checks the position of the snake's head and the dimensions of the game board to see if any moves would cause the snake to hit the boundary. So this coding should assess the movement of the snake by assessing the dimensions of the game board to avoid hitting the boundary. If a move causes the snake to go out of the bounds, it declares that the direction is unsafe by setting the corresponding entry in the move safe dictionary to false. The is underscore move underscore safe dictionary, which is initialized at the start of the move function, keeps track of which moves are safe and which are not based on various conditions such as wall collisions, self collisions. Uh, this ensures that the snake does not move towards the wall. Instead of considers only safe moves that keep it within confines of the pole. So the snake must assess its own self and surrounding, like the board's height, board's width, and snake's movement to avoid collision with the body and collision with the walls. This is the video of avoiding the wall. As you can see, it's not hitting the wall, it avoids and eats the food too at the same time. Okay.
Good afternoon. My name is Navin Kumar Selvam, and my matrix number is CN200109. So now I'm going to slightly explain and present about our Battlesnake project, about one of the challenges. So I am going to present about challenge 3. So challenge 3 is about avoiding hitting the wall. The snake should not hit the wall. So the solution for this problem is we create an algorithm for it to check whether the body is in the cell, so that the program will identify it as an invalid move. So the cell that contains the body of the snake, the algorithm will think that it's an invalid move, so it will check and choose the move to avoid. As in challenge 2 is to avoid wall, and it will in challenge 3 it's about avoiding itself, colliding with itself. So it will do checking, because in this coding we have invalid move checking algorithm. So this function of the snake body beginning with the second element to see if any body parts are in the position as the snake said. If the snake collide with any body part, it means it's the result collide with itself if it move in the direction. As a result, the corresponding move in the is move dictionary is marked as unsafe by setting the entry to false. Ensure that the snake does not move into its own body and only consider safe move to avoid colliding with itself. The AI algorithm avoids moves that would cause it to collide with itself by marking this action as an unsafe due to collision. So as you can see, this is the coding. Yep. So the body part 1, if the head is X, body part 8, you will calculate to find a valid safe move. So this is an example video of the snake trying to avoid hitting itself maximizely. But when a snake gets longer, it tend to collide with itself. But when it's small, it tend to there's improvement after a lot of made. As you can see, it could collide here, but it already avoided it, and it can also collide here, but it avoided it, and followed by similarly it can also be collide over. Yep. So as we can see the example, you can collide over here as well, but it managed to go in a zigzag way, so that the snake tend to get collide with itself and it's become too larger. So I have tried to rectify this issue. as much time as possible, but the outcome is still the same.
Okay, we will move to challenge 4, which is avoid hitting the opponent's snake. Okay, I will present a captivating video showcasing our battle snake remarkable ability to avoid collision with other snakes. In this video, you will witness our battle snake in action, navigating the dynamic battlefield with precision and agility. As it strategies it moves, you will see how it intelligently evaluates potential collision and gracefully maneuvers to steer clear of other snakes' path. Our battle snake's success lies in its implementation of the move, a critical component that ensures the safety of its every move. By verifying each potential step, our snake sidesteps danger and stays focused on our maneuvering opponents. Throughout the video, you will be amazed by the calculated decision our battle snake makes, avoiding its own body and deftly evading other snakes. Witness its ability and quick thinking as it reacts to changing situations on the board. Okay, for challenge 4, avoiding collisions with other snakes. To achieve this, our battle snake utilizes the move, which plays a vital role in verifying the safety of potential move. This function follows a rigorous process to determine if a move is a safe. For number 1, it calculates the position of the snake's head after the move is executed. Number 2, it checks if the move will lead to collision with the game board's boundaries. If it does, the move is flagged as invalid. Number 3, next, it examines whether the move will cause the snake to collide with its own body. If this is the case, the move is marked as invalid. And for the last one, the function analyzes whether the move will result in a collision with the bodies of other snakes on the board. If such a collision is immediate, the move is also qualified as invalid. By rigorously performing these checks, our battlesnake ensures that its moves are safe and strategically sound. This crucial aspect allows our snake to navigate the battlefield skillfully, avoiding potential dangers and staying in the game longer.
For challenge 5, the solution is try to move towards the food. Uh, Solutions that move towards the food includes to determine whether there's food is available on the game board uh, using Euclidean distance. Calculate the distance between the snake and head and all available food, and determine the shortest distance with the food and avoid colliding yourself. Iterate through valid moves and is move underscore dictionary, say underscore safe dictionary, selecting the moves that bring the snake closer to food. If multiple safe moves lead to the nearest food, let's evaluate underscore futures underscore scenario. To evaluate future scenarios for each move and select the move with the highest evaluation score. If no safe move lead to any food, use find underscore safe move to select a random safe move. If in this is like there's alternative way where if evaluate future scenario is for uh, searching the highest or the best move. If there's no safe move, it will use another uh, coding which is select random safe move. These are the two, and the snake will be able to detect the food available on the game board and move towards it by using the shortest distance or also avoiding other snakes too. Now we'll see the video of the snake moving towards the food. you can see it's moving towards the food uh, using shortest distance. Okay, that's all from me. Thank you.
Next, I will just go through about the result and I will show about the video presentation. So, as a result, this is the first step. We should create an Battlesnake ID for our snake, and the URL is the URL we should put from the coding replit to put here for us to able to control the snake. So this is the result of the snake, the snake going in, avoiding other snakes, avoiding wall, avoiding colliding with itself, and going through the foot based on all the challenge 1, 2, 3, 4, and 5. And this is an example. I will show the video in the video presentation, and I will this is an example of uh, of the snake avoiding and winning the game. As you can see, we put 8 battle snake in here, bought battle snake, and you can see we won this. Okay, so next for the video presentation. Hi. So now I'm here going to explain about our battle snake from the website itself to show a video presentation about. So first of all, this is the homepage of our my battle snake, and this is the homepage of the coding environment of Replit. So first of all, we should run here, and we should take the website over here and paste it over here, and then we can press for save. So when it's safe already, we can go for create game, and we can just add our bot to the game, and we can just start the game to see the challenge 1 to 4, which is avoiding the wall, avoiding the colliding itself, and going towards the foot. So we can see this is happening also until it's avoiding itself, it's avoiding the wall and every such etc. as based on the challenges, but with the snake tend to collide with itself or go out of bond when it's became longer. So next I'll show about the avoiding other snake, which we add official bot. For example, we put 3 bots, um, yep, and we just start a game, and we can see our snake hit with cells, and we can check again one more time. And see the snake is avoiding other snakes and going towards the foot, and eventually collide with itself. So that's all from my side. Thank you very much.
Okay, for milestones, we have 4 weeks to finish our Battlesnake AI project, which is week 12, week 13, week 14, and week 15. Okay, for conclusion, upon completion of all the 5 challenges, our Battlesnake is ready to compete with other snakes. After many trial error, we made reliable Battlesnake that can compete with another snake. Although it is ready, the room of improvement in future is high. In conclusion, the application of knowledge learned from AI, such as BFS search, TFS search, A search, GBFS search, and more, came in handy to develop this better snake.